There is a specific kind of violence in military procurement that the general public never witnesses. It is not the sudden violence of a kinetic missile strike or a high-G dogfight over the Pacific. It is the sterile, quiet, administrative violence of a budget pen moving across a sheet of paper in a windowless Noom in Virginia. In February of 2024, a group of generals signed a document that effectively executed the future of Army aviation. With a single calculated stroke, they canceled the Future Attack Reconnaissance Aircraft Program, universally known as FARA. In doing so, they left a $1 billion masterpiece of aerodynamic engineering sitting in a dark hangar at West Palm Beach, permanently stripped of its mission and grounded before it could ever fire a single shot in anger. That machine is the Sikorsky Raider X. If you listen to the carefully sanitized press releases, they will tell you that the helicopter era simply evolved. They claim that the lessons learned from the brutal attritional warfare in Eastern Europe proved that manned reconnaissance helicopters are fundamentally obsolete. They say that swarms of cheap, expendable drones have rendered this entire architectural concept irrelevant. But I don't read the public relations brochures. I read the telemetry data. I look at the unvarnished physics of a machine that was explicitly designed to break the laws of flight. The Sikorsky Raider X was not a failure of engineering. It was the most advanced, aerodynamically lethal weapon system ever conceived. It was the knife fighter, a platform built to hide in the acoustic shadows of urban canyons and fly at dash speeds that would rip the rotors off a standard Apache. I'm James. Welcome back to the Hidden Muster. Today, we are performing an exhaustive forensic autopsy on the execution of the Raider X. We're going to rip the composite skin off this aircraft and look at the physics that made it a miracle and the geopolitical shift that made it a target. To understand why the loss of the Raider X is such a profound blow to military aviation, you have to understand the cage that standard helicopters have been trapped in for 80 years. Conventional rotorcraft, whether it's a Black Hawk or a Russian Havoc, rely on a single main rotor disc. As that rotor spins and the helicopter flies forward, the physics become wildly asymmetrical. On one side, you have the advancing blades. They are moving toward the front of the aircraft, so their rotational speed adds to the helicopter's forward speed. They generate massive amounts of lift. But on the other side, you have the retreating blades. They're moving toward the rear, meaning the helicopter's forward speed is subtracted from their rotational speed. As you go faster, that retreating blade has to tilt at a steeper and steeper angle to keep the aircraft from flipping over. But physics imposes a terminal limit called retreating blade stall. Eventually, the angle is so steep that the air simply detaches from the blade. It stops flying. On the other side, the advancing blade tips are hitting the speed of sound, creating shock waves and massive drag. This is the aerodynamic cage. It hard caps conventional helicopters at a top speed of roughly 150 to 160 knots. You cannot simply drop a bigger engine into an Apache to make it go 250 knots. You would just induce a catastrophic roll and crash faster. Sikorsky decided to shatter that cage using X2 architecture. Instead of one rotor, the Raider X uses two rigid coaxial rotors spinning in opposite directions on the same mast. This deletes the asymmetric lift problem. When the retreating blade on the top rotor stalls, the advancing blade on the bottom rotor is there to catch the load. The lift remains perfectly balanced, no matter the speed.
This architecture opened a door that had been locked since the days of Igor Sikorsky's first prototypes. But you can't just stack two rotors and call it a day. If you put standard flexible blades on a coaxial system and try to fly at 200 knots, the intense turbulence would cause the upper and lower blades to flap and collide, destroying the aircraft in midair. To solve this, Sikorsky engineered ultra-rigid carbon composite blades. These blades do not flap. They are so stiff they hold their horizontal plane with millimeter-level tolerances, even when subjected to extreme G-loading. By combining these rigid rotors with a state-of-the-art digital fly-by-wire system, Sikorsky created a lift-offset system. This ensures that the advancing blades carry the primary load of the aircraft's weight as it moves at high velocity. The Raider X proved that you could fly a rotorcraft at dash speeds exceeding 250 knots, nearly 100 knots faster than the current fleet, without worrying about the aircraft losing control. This is the speed domain of fixed-wing turboprops, but the Raider X maintains the ability to hover precisely over a fixed point. It isn't just a faster helicopter, it is a fundamental shift in how we manage aerodynamic stability. Under the cowling, the Raider X was designed around the General Electric T901 GE900. This engine is the result of the Army's Improved Turbine Engine Program, or ITEP. The Pentagon's requirement was brutal. Build an engine that fits in the same physical footprint as the legacy T700 used in Blackhawks, but make it generate 50% more power and consume 25% less fuel. The T901 is a mechanical beast, generating 3,000 shaft horsepower. In a standard helicopter, much of that power is parasitic. You have to bleed off a massive percentage of power to spin a tail rotor just to keep the fuselage from spinning in circles. It's waste in energy. Because the Raider X uses counter-rotating rotors, the torque is naturally canceled out. There is no need for a tail rotor. This means nearly 100% of that 3,000 horsepower is routed through a high-tech split-torque gearbox and used exclusively for lift and forward thrust. This gives the Raider X a power-to-weight ratio that is absolutely terrifying. It can operate in high-hot environments like the mountains of Afghanistan or the sweltering Indo-Pacific without the performance degradation that routinely grounds conventional helicopters.
The most distinctive feature of the Raider X is the six-bladed reversible pitch pusher-propeller at the tail. In a traditional helicopter, the main rotor does everything. It provides lift and tilts forward to provide thrust. This forces the pilot to point the nose at the dirt to gain speed, exposing the belly to ground fire and blinding the nose-mounted sensors. The Raider X decouples these forces. The main rotors handle the lift, while the rear pusher prop handles the thrust. It drives the aircraft forward with a raw violence that no standard helicopter can replicate. But the true tactical genius is the zero-flare deceleration. To land quickly, an Apache pilot has to flare, pitching the nose up sharply to use the rotor disc as a massive air brake. It's a vulnerable maneuver. The Raider X doesn't need to do that. The pilot can command the tail propeller to reverse its thrust vector. The prop becomes a massive aerodynamic brake, slamming the aircraft from 200 knots to a dead hover in seconds, while the fuselage remains perfectly level. The 20mm rotary cannon and targeting sensors stay locked on the target the entire time. This is why it's called the knife fighter. It can fight in a phone booth. The FARA program wasn't just about speed. It was about the looming strategic nightmare of the future megacity. Military planners realized that the next wars won't be fought in open deserts, but in sprawling urban jungles with populations of 20 million. In a megacity, traditional radar is degraded by skyscrapers, and fixed-wing jets like the F-35 fly too fast to find targets in narrow streets. The Raider X was designed to be the king of this environment. Its coaxial design removes the need for a long tail boom, giving it a much smaller physical footprint than an Apache.
It can navigate narrow, concrete canyons and land in small parking lots or rooftop zones that would be death traps for other aircraft. Its rigid rotors provide instant control authority. It responds to pilot inputs with razor-sharp precision, allowing for lateral slides and high-rate turns in confined spaces. It's a ghost that sneaks through the radar clutter, pops up to identify a target, and drops back into the shadows before air defenses can react.
The Raider X also addressed the helicopter's greatest weakness: noise. Most helicopter noise comes from the tail rotor and blade vortex interaction, where blades hit the turbulent air of the blade in front of them. By deleting the tail rotor, Sikorsky removed the highest frequency acoustic signature. But they went further. Using the digital fly-by-wire system, the Raider X can enter whisper mode. The computer slows the RPM of the main rotors to the absolute minimum required for lift, relying on the efficiency of the rigid carbon blades. It then clutches out the pusher-propeller entirely. The result is a heavily armed attack helicopter that produces an acoustic signature lower than a light civilian news helicopter. In a noisy city, the Raider X could get within a few blocks of an enemy post before being detected. It replaces the thump-thump-thump early warning of an approaching helicopter with sudden, point-blank kinetic dominance. If the Raider X is an engineering miracle, why did the Army kill it? The answer lies in the blood-soaked trenches of Ukraine. FARA was conceived in a pre-Ukraine world, but the last 2 years have proved that the battlefield is now completely saturated with ubiquitous, low-cost sensors. Every infantry squad has a drone with a thermal camera. There is no such thing as hiding in the ground clutter anymore. A multi-ton aircraft burning jet fuel is detected the moment it takes off. Once detected, it faces a catastrophic attrition rate from manpads and integrated air defenses. The U.S. Army watched advanced helicopters on both sides of the Ukraine conflict being forced to operate miles back from the front line, firing unguided rockets in high arcs just to stay alive. The Army did a cold mathematical calculation. Why spend $40 million on a single Raider X and risk 2 pilots when a $5,000 FPV drone can carry a shaped charge and destroy the same tank? The democratization of surveillance turned the manned reconnaissance mission into a suicide run. Furthermore, the Army had a budgetary crisis. They couldn't afford FARA and the V-280 Valor, the massive tilt rotor replacing the Black Hawk. They chose the workhorse, troop transport, over the knife fighter, scouting. They sacrificed the Raider X to pay for a future of robotic drone swarms and long-range assault.
The Raider X is a tragedy of timing. It is a masterpiece of mechanical engineering built for a vision of warfare that was shattered by the reality of the drone war. The technology itself isn't dead. The physics of the X2 architecture will likely live on in classified special operations platforms or unmanned high-speed combat drones. But the era of the manned scout pilot is over. The Raider X was too late for the old wars and too expensive for the new ones. It remains a phantom of what could have been, a billion-dollar reminder that in the world of high-tech defense, the laws of physics are often easier to break than the laws of the budget. I'm James. This has been a forensic autopsy for The Hidden Muster. Keep your eye on the telemetry coming out of the advanced drone programs, and remember, in this game, the pen is often far more lethal than the trigger. We're out.